everyone, this is Shainna from 9B. My physics teacher Himani ma'am gave me this opportunity to make self-made videos demonstrating the Newton's laws of motion. So let's start. The great scientist Sir Isaac Newton gave us 3 laws to describe the motion of the bodies. These laws are known as Newton's laws of motion. These laws of motion gave us a precise definition of force, and they also established a relationship between the force applied on the body and the state of motion acquired by it. So today we will discuss the 3 laws of motion, and we will also discuss some day-to-day applications based on them. So let us start with the first law of motion. According to Newton's first law of motion, an object will remain at rest or an object will remain in state of uniform motion until and unless an external unbalanced force is applied on it. Let us take some examples to make the first law of motion more clear. So you can see that this book is lying on the table and it is at rest. This book will not move by itself, or it will not change its position by itself until and unless an external unbalanced force of our hand will be applied on it. That is, when we lift the book, then the state of rest has been changed by this book when we applied the unbalanced force of our hands. And this observation supports the first part of the first law of motion. The tendency of a body to remain at rest, or if moving, to continue motion in a straight line is called inertia. Newton's first law recognizes that every body has some inertia. Greater the inertia, greater will be the force required to change its state of rest or of uniform motion. Let us take an example to make this statement more clear. So I have taken 2 balls of different masses, so we can easily see that this ball has lesser mass than this one. So I will apply the same force on both these balls, and then we will observe the differences. So first I am applying force in this ball, and now the ball with the greater mass. So you can see that when I applied the same force on the ball with the less mass, this ball moved a very long way, but in comparison to this ball did not move. So we come to an conclusion that inertia depends on its mass. According to Newton's second law of motion, the rate of change of momentum is directly proportional to the force applied, and it takes place in the direction in which the force acts. Newton's second law of motion gives us a relation between force and acceleration. Newton's second law of motion also gives us a method of measuring force in terms of mass and acceleration, which can be calculated as F is equal to m into A, where F is equal to force applied, m is equal to mass of the object, and A is equal to acceleration produced. So let us take an example of Newton's second law of motion. A cricket player moves his hands backwards on catching a fast wicket ball. This is done to prevent injury to the hands. A fast-moving cricket ball has a large momentum. In stopping this cricket ball, its momentum has to be reduced to 0. Now, when a cricket player moves his hands back on catching the fast ball, then the time taken to reduce the momentum of a ball to 0 is increased. Due to more time taken to stop the ball, the rate of change of momentum of ball is decreased. and hence a small force is exerted on the hands of the player. So the hands of the player do not get hurt. According to Newton's third law of motion, whenever one body exerts a force on another body, the second body also exerts an equal and opposite force on the first body. The force exerted by the first body on the second body is known as action, and the force exerted by the second body on the first body is known as reaction. So now we can give another definition of Newton's third law of motion. That is, to every reaction there is an equal and opposite reaction. Action and reaction forces act on two different bodies. Let us take one example to illustrate Newton's third law of motion. When we walk on the ground, the foot pushes the ground backward, and in return the ground pushes our foot forward. This forward reaction exerted by the ground on our foot helps us move forward. Till now we have discussed the Newton's three laws of motion, and now I would like to thank my physics teacher Himani ma'am for making all the concepts crystal clear to me, which helped me to make this video. She was a great source of inspiration for me till time. Thank you very much.